solve the equation exactly without using a calculator. Your answer may contain one or more logs or natural logs. So we have an exponential equation, and on both sides of the equation these exponentials have different bases and they're not the same base numbers. Had this been 8 instead of 7, we could rewrite these both as base 2 and have a much easier problem. Instead, we have a need for another way to essentially solve for these x in the exponents. So what we're going to do is we're going to take log of both sides. I'll do natural log. You could use common log as well. In fact, you could use a log base 7 or log base 4 and then use another, use the change of base formula to simplify in a different approach. But what this allows us to do, having this log, is to bring this exponent out in front. Now it still leaves the 7 and the 4 inside the logarithm. This parenthesis around the exponent is actually really important because this exponent is grouped by being in the exponent, and it's about to come down as a coefficient. And I'm going to write the left side and the right side differently so you can see the need for the parentheses. So on the left side, the 5 is the coefficient of the natural log of 7. But the entire 3x minus 5 was the exponent. So the entire 3x minus 5 should be the coefficient. On the right, the 2x plus 1 is the coefficient correctly. So this parenthesis is critical. So what we have done by taking natural log of both sides is we've made the exponent that has the x in it down in front where it's now easier to solve. We now need to distribute, because we're trying to solve for x, and there's two different x's. We need to get them all loosened up and on the same side. So we have 3x ln of 7 minus 5 ln of 7 equals 2x ln of 4 plus 1 times ln of 4. Okay, looking better. We want all the x's on the same side. So I'm going to subtract this 2x ln of 4 on the left. It's not a like term with anything over here, so I can't add or subtract them specifically and simplify, but it does have an x and we want all the x's on the left or on one side. And I'm also going to add this 5 ln 7 to the right. Again, not a like term, so it doesn't simplify, but we need to move it around. We now have 3x ln 7 minus 2x ln 4 equals, these are gone, 5 ln 7 plus ln 4. I don't know why I put it in that order. You could switch the order around if you'd like. The left one I put the positive first. Now we can factor out the x, and this step allows us to go from where there are two x's to where there's just one x. And we need to solve for x, so we can't have two x's floating around. That's why we had to get them on the same side. That's why we had to distribute through the parentheses, so we could move them separate from the other parts without x's. And that's why we had to do the natural log to get these down in front where we could work with them. Final step to solve is to divide by this coefficient. Although it's a binomial with crazy looking things inside it, it's just a single number if we were to evaluate it. We divide by this number on both sides. Oops. And nothing simplifies, but we have succeeded in solving for x. X equals 5 natural log of 7 plus natural log of 4 divided by 3 natural log of 7 minus 2 natural log of 4. And that's the exact value. We wouldn't want to go to a calculator because then we just get an approximation, which is not what we want. We want the exact answer. And it does say solve the equation exactly without a calculator. All right, I hope this helps.